Hello. And this week we're going to be looking at synthesis of biodiesel. So renewable energy and a way to power our vehicles and other things without depleting all of our fossil fuels is a hot button issue right now. Because we only have a finite amount of fossil fuels that we can continue to burn before we run out of them. Not to mention, fossil fuels don't always produce the cleanest energy possible out there. So lots of people look at lots of different alternatives. One of these alternatives is this biodiesel, where we can take some sort of an oil. In this situation, we're going to be looking at some vegetable oil. And we're going to use that vegetable oil in order to form a biodiesel, which is a fuel that comes from this vegetable oil. We're going to take some calcium hydroxide. We're going to react it with some methanol to make some calcium methoxide, which acts as a catalyst reacting with our vegetable oil in order to form our biodiesel. We'll get some triglycerides and some glycerol. And ultimately, we'll get a diglyceride that we can then test and see how good did we do with our synthesis. Now, this particular reaction requires a 48-hour sit time before you can test everything. Obviously, I'm not going to leave this video running for 48 hours. I'm going to show you how to set everything up, and then I'm going to show you how to test your biodiesel product with something that I have off to the side. All right, so I'm going to button up here. All right, or snap up rather. Okay, and then we'll put safety goggles on. And our gloves here. Okay. So for this investigation, we need a few things. We need the baggie that says synthesis of biodiesel. Inside, you will find vegetable oil with its own dropper. You will find some methanol, some pH paper, and a couple of glass items that are wrapped together in bubble wrap. Those glass items are your little vial to make your biodiesel in, your calcium hydroxide. Okay, and so we'll take all of the wrapping off. I'm going to use my pen. Poke through that. There's my methanol. And the plastic sticks to the gloves. Or it could just be the air out of my garage this morning. All right, so there are all those things. And then now, from our general equipment kit, we need our 10 mil graduated cylinder, another pipette, our electronic balance, and our glass test tube. All right, so how do we go about making our biodiesel? Well, for the first thing we want to do, we want to get our balance and turn it on. And then we want to weigh out some calcium hydroxide and get it into the 3-gram vial. Now, there's two ways you can do this. You can try to weigh it directly into the vial, which, because of the narrow opening on the vial, will probably be a little bit difficult. So I would recommend getting out a weigh boat, okay, putting that on there and hitting the tare button, and then getting one of your spoons. You won't be able to dip the spoon into the calcium hydroxide, but I think it's easier to weigh this out if we take the calcium hydroxide, tap some into the spoon, and then put it into our weigh boat. Now, you don't need much calcium hydroxide, so this is why I recommend putting in the spoon first, because if you put too much out, it's easy to take care of. Okay. Your balance should give you that 0.2 grams. Depending on the air that's going on around you, it might take a bit for it to get up. Yeah, like mine now is giving me way more than I need. So I'm going to put some of this back. There we go, that looks better. It's okay if it bounces a little bit. You know, if you accidentally get 0.3 instead of 0.2, that's not the end of the world. Right, and then I can create a funnel system with my weigh boat here. and put that into my vial, and then I can set this off to the side to be washed later. Tear that. I'm going to turn this off because I don't need it for a little while. Okay, so now I have my calcium hydroxide. Okay, my next step is to measure out 8 mils of methanol with the graduated cylinder. Okay, the easiest way to do this, instead of trying to pour into the graduated cylinder, is to go ahead and use a pipette. I'm going to squeeze out from my pipette, put into my graduated cylinder like this. This allows me to control it better than if I was just pouring it from the bottle. All right, there's my 8 mils. Cap my bottle. Okay, so now I'm going to add this to the vial. And I'm going to cap it and shake it. Okay. Want to shake it really, really well. So now what you want to do though is you want to go ahead and let that sit for about 10 minutes, okay? Picking it up here and there to shake it occasionally. That gives the calcium hydroxide and the methanol time to react with each other, all right? Okay, so we pick it up and shake it. And I'm going to do an accelerated 10 minutes, i.e. I'm not going to let it sit for the full 10 minutes, okay? When you've done that, you want to open it up away from your face just in case any pressure is built up. Okay. And then what you will do is using the pipette that came with the vegetable oil. Okay, you'll want to go ahead and rinse this out. So I'm just going to grab another one. Okay, so that way you don't have to wait for me to wash stuff in the middle of the video. Okay, and now this says we want to use about 1 milliliter of this. Okay, so I'm going to do the same thing I did with the methanol. Okay. The other thing you can do technically is there's about 20 drops in 1 mil. So if you don't want to use a graduated cylinder for this part and you want to instead count out 20 drops, you're welcome to do that. The only problem with counting drops of vegetable oil is the oil is a little bit different when you try to count drops. And it's a little bit harder to control the drop formation than it is with something like water or the methanol. So if you want to simply count 20 drops instead of measuring out a mil, that's perfectly fine. Just you have to be very careful controlling those drops. Okay, and then you add this to your vial. Okay. That process had to be washed. And again, you will shake. Okay. And then you're going to have to let this sit for 48 hours at least, because you want to make sure that everything has time to react. This is not a very fast reaction because remember, first that calcium hydroxide has to react with the methanol to form the calcium methoxide. Then the calcium methoxide has to start to react. And then a third step is where we finally react with the vegetable oil in order to form our final product. So there's 3 steps that have to happen here, which means this needs time to sit, but it does need to be mixed properly. So every once in a while, you'll want to shake it up. So you might want to put this somewhere that is not in your way, but in your, sphere of influence enough that maybe you walk by and go, oh yeah, I need to shake that. So you walk by, you shake it for a minute and you put it back down. And then maybe a couple hours later, you walk back by, oh yeah, I need to shake that a few times and then set it down. And you do that over the course of your 48 hours. Okay. All right. Then we want to test the quality of it. So our data table here has spaces for mass of various different things, density, pH, and presence of intermediates, yes or no. So I have my data table. I have my ink pen that I can write with. And what I need to do is I need to do some quality testing. So I'm going to show you how to do the quality testing, but I'm going to do it with some water here, just because obviously we don't have 48 hours for the video to just sit here. So I'm going to pour out a little bit of water so that I can show you how to do the testing part. All right. Now, in your vial, though, all right, okay, so there's my lovely picture of a vial. Okay, in your vial, you'll have liquid, but there will be 2 layers at least. Okay, the top layer okay, your top layer is going to be your biodiesel. Okay, so when you are pipetting out of this, you want to put the pipette in just at that top layer there. Okay, so try not to bring the pipette all the way to the bottom of the 2 layers, but try to put it at the very, put it toward the top of that. And then if you need to put it in a little bit more as you extract some out, you can. But the closer you put the pipette to the bottom layer, the more likely you are to accidentally pull up the bottom layer instead of just the top layer. So you want to put that pipette into the top layer so that you can extract out of the top layer. Okay. All right. So our first thing is going to be figuring out what the density of our, we're going to do that by taking a graduated cylinder. We're going to turn on our balance and we're going to mass out our graduated cylinder. So we want to get the empty graduated cylinder. So mine weighs 11.19 grams. So I'm going to write that down, 11.19 grams. Okay, and then we want to get approximately 1 mil. Now we say approximately because what you're going to do is you're going to use your graduated cylinder and your clean equipment. Okay, and oh, I put a little bit more than 1 mil, but that's okay because I'm going to write down the exact volume that I just dispensed. So I dispensed, it looks like 1.22 milliliters. So that's what I'm going to put down. 1.22 milliliters. Okay. Now I'm going to weigh my balance or my graduated cylinder again. And now I have 12.16 grams. Okay. So I need to figure out the mass of my biodiesel. And so to figure out the mass of my biodiesel, what I'm going to do is take that mass of the graduated cylinder with my stuff in it, which was 12.16 grams. And subtract from it the mass of my graduated cylinder empty, which was 11.19 grams. And I'll pick up my trusty calculator. We're going to do 12.16 minus 11.19, and I'm going to get 0.97 grams. And remember that density is grams over milliliters. So I have 0.97 grams divided by my 1.22 milliliters. Okay, so divided by 1.22 gives me 0.79 grams per milliliter. Okay. All right, and so that's how you're going to figure out the density of your biodiesel. Okay. All right, so I would write down my 0.97 grams and then my density, which was 0.79 grams per milliliter. And there's space under the observations area where you can also write some calculations if you need to. All right, the next thing that we want you to test for is the pH. Okay, now the instructions say to dip the pH paper into the biodiesel. That's not actually the best way to get the pH. So this is really cool. They give you plenty of pH paper. They give you enough to do lots of different things with because you really only need one little piece. So I'm going to pull out from my little envelope here my indicator that lets me know what the different pHs are. And I'm going to pull out one piece of pH paper. I'm going to put the rest back in this envelope so I can use it for something else later on if I need to. And now what I want to do is that pipette that I used a few minutes ago to extract my biodiesel from my vial is already contaminated with the biodiesel. So that's perfect. So what I'm going to do is instead of dipping my paper into the biodiesel, I'm going to take my pipette and just dip it in there. So I'm going to get a little bit on the tip of my pipette and then I'm going to dot it on my paper. I'm going to do that again, get a good dot. Okay, and I can even do that on the other end of the paper if I need to, just to verify. Okay, and so then I'm going to let that sit for just a moment. And then I'm going to look at my little key here, and I'm going to compare the color. And hopefully, because I use deionized water, I don't have a crazy pH here. And I'm going to look at this, and it looks like my pH is about 6. Okay, so that's what I'm going to put down from the pH of my biodiesel. Is looking at the colors. It looks like my pH is about 6 based on that color there. And I can look at both sides where I dotted both of them and they look consistent there. All right, and so that is going to be how I determine my pH. Now, this little key tells you, 1, 2, 3, 4, 5, 6. If you think a color is somewhere in between, like let's say you look at it and you don't think the color is quite pH 9, but you don't think it's quite pH 10, you can go ahead and put down pH 9.5. That's perfectly valid, okay? And then I'm going to put this back in here so I can use it later if I want to, okay? And then all of this stuff I can wash. This piece of pH paper that I've used, though, this can go in the trash. All right, and then the last thing we want to do is we want to test for the presence of other stuff that's in there. And so what we need to do is we're going to take our glass test tube and we're going to put some the biodiesel into the test tube and then add some methanol. And then you're going to shake up the test tube, okay? And then you're going to let it sit for about 10 minutes. And then you're going to come back to it and take a look at it. If there's an insoluble layer that forms, that means that there's some unreacted stuff in your biodiesel, and so that you would then have intermediates. If no layer forms, you don't have intermediates. All right, so all you're doing is saying yes, you have intermediates if that layer forms, or no, you don't have intermediates if that layer does not form. Because this has to sit for about 10 minutes, I would actually recommend doing this step first. Get this in there, shake it up, okay, let it do its thing, and then set that off to the side, and then do your density test and your pH test. That way, that can be sitting while you're doing everything else. Part of being in a lab sometimes is figuring out, do you have to do everything in exact order? Or are there things that you can set up while you work on other things and then come back to it, thus maximizing your time and not just wasting? Since you're at home, it's not as big of a deal. Because you can obviously take all the time that you need to do these labs. But if you are in a research lab where you're under a time crunch, like say you're doing undergrad research at a university and you slip into your lab to do something in between classes, maybe you only have so much time before you have to get to your next class. Or if you're in a teaching lab, in a normal semester where we only have those 3-hour periods, sometimes you have to maximize your time properly in order to get everything done in the class period. So that is your experiment this week. Hopefully you find it pretty cool. I think that, again, exploring those alternative energy sources and figuring out things that we can do to power stuff without having to just dig into fossil fuels is really important. And this is a cool reaction because you do have to go through some intermediates before you can make that final product. And quality testing is always something that's really important when you're doing a synthesis reaction. And so this quality test that you do at the end gives you some good clues into how good your reaction was. And, like if I were to test mine right now, because I only let it sit for a few minutes, I would probably have a whole lot of unreacted junk in mine. So make sure you do let yours sit for that good 48-hour period. And like I said, every time you walk by, I'm just going to shake it up and then I'm going to set it back down. Okay, and that way everything reacts. Because if it settles too much and the layers start to form, then you may not get everything to react properly, which is why you do have to shake it up every so often. And then before you do your quality test, make sure you let it sit for a long enough time that those layers do form. You don't want to shake it up and then immediately try doing your quality test, because your layers won't have reformed, and then it'll be really hard to pull the biodiesel off. So that is our reaction this week. Hopefully you find it interesting, and that is all I have for you this time.